got a year 11 and 10, this is a nice, quite tricky graph transformation question for Minh Duc, and it's a trig graph that has had some stuff done to it. And we're given the form of the equation, and we have to figure out what the values are. So we're showing that the diagram shows us part of the graph of y is equal to a tan of x minus b plus c. And we have to figure out the values of a, b, and c. So I think the easiest way to start here is to draw a really bad sketch of the basic tan graph, right? And it looks like this. Key things to note in there, even when it's drawn badly, are that it's got a point of symmetry, rotational symmetry in here. And so for some of you, you're probably going to spot where that is on that graph. I'm not that good at spotting symmetry patterns, so I guess the slower way to do this is to look at what's happened to the asymptotes. If you think about your basic tan graph, then one of the key features is that the asymptote is at pi on 2, and then it's at 3 pi on 2, and so on. So it's here, right, and it's here. So let's have a look at where the asymptotes got to in our graph. And again, just use your ruler to do this. Right, you can see that the asymptote in here has moved out to 3 pi on 4. So that's telling us that it's been shifted horizontally. And that's the easiest one, I think, to get first here. So instead of being at pi on 2, it's at 3 pi on 4. That means that b is equal to pi on 4. Right, and if we had to write that up nicely, we'd say that the function y equals tan x has been translated by pi on 4 units parallel to the x-axis, in the positive direction of the x-axis, something like that. Now, once we've got that, it gets a little bit easier to look at the next two things. So here, this is at 90, this is back at 0. So let's go back pi on 2 or 90 from where the asymptote is. So we're moving back to here, to pi on 4. And this point usually would be at 0, but we can see that it's up here at 1. And now that I've drawn that on, I think it's kind of obvious that that is kind of the center of rotational symmetry. That means that we've got a vertical shift here of 1. So we're just about done. We've got y is equal to a times tan of x minus pi on 4 plus 1. Now the hardest thing to work out in here is what's the vertical stretch. But again, if we go back to our basic tan graph, let's pick an easy point on here. So tan of pi on 4, we know from our special triangles, is equal to 1. So the function that we're working up to here is that y is equal to a times tan of x minus pi on 4 plus 1. So if I want to figure out the special value point here, I'm going to put x of pi on 2 in here, right? So that this whole thing becomes pi on 4. So y is equal to a tan pi on 2 minus pi on 4 plus 1. So y is equal to a times 1 plus 1. Let's see what our value is here. So if there's no scale factor, if there's a scale factor of 1, then we should be seeing that we're at 2, but we're not. We're up here at 3. And that means that I've got this. I've got 3 is equal to a plus 1. So a is equal to 1. In other words, there's been a stretch in the direction parallel to the y-axis with a scale factor of 2. Sorry, 3 take away 1 does not equal 1. 3 take away 1 equals 2. There we go. So a equals 2. So my final function is this. Y is equal to 2 tan of x minus pi on 4 plus 1. Now I've gone through that really slowly because I think this is probably the hardest of the graph transformations with trig functions that you do. It's definitely less intuitive than when you're working with a sine or a cosine. So great question. Keep on sending them in and I will do a few more videos over the next few days. Thanks for watching.